So for today's assignment, we're going to look more at functions. And you'll remember, again, this is a bit of a review. That we write a function, we can write it as f of x, and the x is what goes in, and then what comes out is whatever is on this side of the equal sign. So here we have x going in, and 3x plus 2 going out. And then we can evaluate that by plugging a value in for x. So in this case, we put in a value of 5 in for x. And then as it shows us here, that's 3 times 5 plus 2, which gave us 17. So we evaluated it, we put a value in. Let's take another quick example of that just to remind you. We have where we're supposed to evaluate g of x equal to 25x. So we'll plug in a value of 7 for x is what it tells us to do. We plug in the value it tells us when we evaluate. So we'll take that as g of 7 is equal to, and then we replace everywhere we see x with that value. So there's the 7 there. G of 7 is equal to 25 times 7. Well, 25 times 4 is 100. And then add 3 more 25s, that's 75. So G of 7 is equal to 175. So we've evaluated that function. Now, one of the more common questions you'll get when it comes to functions is, if we're given a certain domain, right? So if we're given a certain domain, let's say we are given the domain 1, 2, 3, and 4. These are the numbers that we'll put into our function, right? Let's say our function is x plus 1. That's our function, and they give us the domain, and they ask us for what is the range, right? So if that's the domain here, then what's my range going to be? These are all the possible input values, then what are all the possible output values? And it really is as simple as evaluating this function for each one of these values. So in this example, we'd plug 1 in, right? That's our first value. So for the domain value of 1, we plug in 1 in each case. So when x is equal to 1, y is going to be equal to 2. So that would be 1, 2. The range includes the value of 2 when x is 1. Well, when x is 2, or our domain value is 2, 2 plus 1 is 3. And when x is 3, 3 plus 1 is 4. And when x is 4, 4 plus 1 is 5. So we just found the range of our function given a particular domain. That's what these problems are. The domain of f of x equal to negative 1.5x plus 4 is this. These are the possible x values that can go into our equation. So what is the range? All we're going to do is evaluate our function right here. Evaluate that function for all of the possible x values, or all of the possible inputs to our function. So we'll write them here, 1, 2, 3, and 4. Well, we'll evaluate f of x, so we'll say f of 1 is going to be negative 1.5 times 1 plus 4 for the input value of 1. Well, negative 1.5 times 1 is negative 1.5. And when we add that to 4, that's going to give us 2.5, because 4 plus a negative 1.5 is 2.5. So we're going to get 2.5 for our value there. And then we would do it again, f for a value of 2. We plug in the 2. It's going to be negative 1.5 times 2 plus 4. Well, negative 1.5 times 2 is negative 3. So negative 3 plus 4 is going to be equal to 1. So there's our 1. And then we'll evaluate again for 3. And we have evaluated. We now have our range. The range of values for this function is right here. I'm going to list it out from least to greatest, because that's what I asked you guys to do. So we'll wind up with negative 2, negative 0.5, 1, and 2.5. And that is the range for this domain. We'll do it again down here. We're given another range, domain of values. So here's our domain, and we'll fill those values in. So let's evaluate for each one, and we'll get our values. I'm not going to evaluate for all of them. I'll let you do this one on your own. But 4 times 1 is 4. Minus 12 gives me a negative 8, right? So g of 1 plug in our g of 1. That's going to give us 4 times 1 minus 12, which is equal to negative 8. Then we'll plug in our next value, which is 3. 4 times 3 minus 12. And since 4 times 3 is 12, 12 minus 12 is 0. And you can fill in the rest on your own. Let's take a look at one more problem. So here's a word problem. You have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 feet. Now we're given the function. We're given the function a times q is equal to 100 times q. A of q, rather, not a times q. A of q is equal to 100q. That represents the area in square feet, and the q quarts of paint cover. What domain and range are reasonable for the function? And then what is the graph of the function? So what domains are reasonable? Well, let's think about this. What are some inputs that we can put in? Well, does it make sense to put a negative input in? Can we have negative quarts of paint? No, we can't have negative quarts of paint, so we're not going to include any negatives. What about 0 quarts of paint? Well, that's reasonable. So we could put in 0 quarts of paint. We could put in 1 quart of paint. We could put in 2 quarts of paint. We could put in all kinds of values. So we have 3 quarts of paint to paint the trim in our house. So we could put in 4 quarts of paint, but we only have 3, so that doesn't make any sense either. So we have 0, 1, 2, and 3. Those are the possible quarts of paint. That's the possible range of values. So in order to graph that function, right, we would need to create a table of values, 1, 2, and 3 right there. And we know that a of q is equal to 100q, so we put in each one of these values. A of 0 is equal to 100 times 0. That, of course, will be 0. A of 1 is equal to 100 times 1, and that's going to be 100. We keep doing that for 2, right? That's going to be 200. We put in 3, that's going to be 300. And then what we would wind up with as a graph, and I don't have time to graph it all out for you with all the numbers, but what you would see is that it would start here at 0, 0, so we know it's a direct proportion. So we can see that, and then at a value of 1, come up here, we'd have 100, right? So that's that. At 2, we'd have 200. At 3, we'd have 300. And we could see that our line would go something like that, right there. And that would be our graph. And that's all there is to it. So take off on the homework. Your homework for tonight is listed in Google Classroom.